All right, let's keep going. Right. So when we want to have more control over the actual operation on the data, when when it can be ambiguous or left to interpretation of what is it that we want to achieve, what we could do is just write a piece of code that indeed will insert from one place and insert into another, or do some manipulation of the data before before updating. This can be triggered when certain things occur. Right? For instance, we can set them up that these execute whenever a change happens, whenever an insert happens, whenever an update, whenever a delete happens, and we can set them up so that we get notified, and so that we can do some massaging of the data before we let it through. Or we might just abort it and say, well, no, we've done some validation that cannot be validated by the constraints on the table, because we could do quite a bit of validation on the table, right? By putting constraints, right? Either unique or maybe we can put a regular expression. We can say all sorts of things. But sometimes we need to go a little further. We need to do maybe a lookup. Maybe we have to do some file lookup or some network connections and verify something, right? Or some very long running transaction. So for that we can certainly do some programmatic. We can create programs to calculate these things for us. Okay, and we have our disposal, a fully programming language, full programming language that can do what any powerful programming language can do. Other things that these procedures allow you to encode everything inside of the database, that it would not be accessible outside, and it gives you some level of security on some of these algorithms, some of these procedures. Well, one of the problems is that the more you use these types of programs, the more you become tied to that particular vendor, right? That particular infrastructure that vendor is pushing, and oftentimes, migrating away from that vendor will be so much more complicated, right? So you can make use of abstractions such as ORMs or jdbc or other layers of abstraction, which would allow you to decouple the infrastructure that you might use for actual storage. If tomorrow you want to migrate your data source to be something else, some other vendor, or maybe you want to go NoSQL, or maybe an object-oriented storage, you can no longer do that, right? Because you've got way too much vested interest in the particular features that a vendor has been providing. Right, they're harder to maintain. The tools that for programming and debugging and maintaining this piece of software is not as powerful and mature as other programming languages. Certainly, they've made a lot of improvements, but they don't rival some of the newer tools for Visual Studio or these very expensive tools that allow you to do reverse engineering and whatnot. Okay, and yet there's yet another language to learn. So there are three types of executables that you can write. They are triggers, functions, and procedures. Now, triggers, what the name suggests, right, are executables that can be tied to various events. Right? If these events occur, then I want these executables to run, so that if somebody's inserting. If somebody's inserting something into a table, somebody's updating something in a table, somebody's deleting, we can configure that on this particular table, if these actions occur, I want this to execute this particular procedure, right? And what will happen is every time anybody does an insert, an update, a delete, or whatever you configured it to, right, it will execute your procedure, and that procedure you'll be able to do things such as, I want to see the table. I want to see the records that are going to participate in this insert or in this delete or in this update, right? And I want to see each record at a time, and I want to see what the values were before and what the values would be afterwards, right? And you have a chance to veto or let it go through and say, yes, that I want that update. No, I don't want that update. Right? Or, yes, I like that update, but I want to massage it. I want to change it a little bit before I let it go through. Right? So it's a very, very, very powerful. You can change the data. They're not meant to return any data. They're meant to execute within the context of some of these events. Right? They're not meant for me to execute them manually. They're meant to be executed as an event that occurs. And yeah, they're reactive. They react on some events. Functions are executables that I can call on the command line. They're not meant to change data. They're meant to run once, compute something, right, and come back with a result. Right, it allows us to abstract things that occur more very commonly, right, like scripts that I wanted to run it once and compute something for me and calculate for something for me. Procedures allow you to, are more powerful functions, right, that allow you to pass arguments, manipulate data inside, right, and maybe calculate that something as well, and do some inserts and change some of that data. And so let's take a look at some of these very simple procedures. We can create a procedure by using the command create procedure. Typically, this would be within an IDE, right? Some editor that you say new, and it opens up that editor, and it wraps all the additional begins and ends, and creates procedures are added by the IDE for you, and then you can just focus on what's inside of the procedure. Now, if you're doing it on the command line, most of the commands that you execute are just plain old SQL, right? And they execute immediately, right? If you do a select or an insert or an update, they execute immediately, as opposed to these are meant to be batched to be executed at a later time, right? I don't mean you to execute it right now. I don't want you to execute the select statement right this minute. Instead, I'm giving it a name so that it can be executed at a later time by referring to the name hello world. Okay. So oftentimes, if you're doing it at the command line, you'll need to escape the default interpretation of the commands, right? And you'll say, well, now I'm in the mode of live execution of commands, and now I am in the mode of programming, right? And there's special character sequences that allow you to switch back and forth, right, between the interpretation of the command line. So oftentimes these delimiters have specific meanings, and that it would allow you to switch back and forth between these two worlds. So things that you can't do in these in store procedure are things such as manipulating schemas, like dynamically creating a brand new table, right, or altering a table, or just removing an existing table. So let's take a look at a little further. Now, the way they execute it, once the procedure is executed, the syntax is slightly different from one vendor to the next. Some of them use call, and then the name of the procedures. Other ones is execute that procedure. So just use whatever syntax is for the vendor, for the particular vendor that you're using. If you want to remove the procedure, you can just drop it, or if you want to change a procedure and add lines or change a particular line, you can use alter. So here's provide a new version of that procedure, alter procedure, the name of that procedure. Now inside it, now typically inside to in the creation of procedure, you say where it begins, where it ends, and any variables that you declare inside of that procedure are local to that one procedure. Although even within a procedure, you can access or manipulate global variables that you might have declared at a higher scope, right? Just like you would expect in a regular programming language. Here's a very simple one that creates the hello world and allows us to just run it by calling it either by just calling the procedure name, and whatever value it returns can be assigned to a variable declared at this particular scope. So this one returns. Now the data types that you're manipulating are different, right? Not only necessarily you can manipulate atomic data types such as integers and strings and dates and whatnot. There's also the data type of the entire table, right? The whole table can be returned, and it can be then assigned to a particular value variable to then be manipulated later. And so in this particular case, we're returning the value 1, 2, 3, and it sets it. So inside when it executes, it's the select hello world, right? It names it by the name of the procedure, and then the calculation of that select statement is just hello world. Here's another one. Two select statements executing, printing out hello world and goodbye, and just returning 1, 2, 3. Here's another a little more involved select statement that you want to execute by name, myproc. You might call myproc, and then it runs the select statement. And presumably this might be a very useful query for you, not necessarily a view that you want to keep around to anybody access it as a table, but you still want to be able to run it, and it presumably might calculate something that is useful for you, maybe a report or some intermediate result that you might need. Now the parameters that can be passed in can be configured at different levels of accessibility, whether there's going to be only data that's going to go into the procedure, or data that's going to come out of the procedure, or data that can go back and forth between the procedure. And that you can specify explicitly what the accessibility is. In is a default, so it's optional. You don't have to put it in, meaning that the data only flows inside. And once it goes inside, it's local to that procedure. Anything that happens to that variable won't be readable from the outside, right? So it's almost like a pass by value, right? So when you're getting a copy, you can do whatever you want with it. It doesn't affect the original result. Whereas in-out allows you to it's kind of like pass by reference, right? I pass you the value, the particular variable, and whatever you do to that variable will be accessible outside of the procedure, right? So it's accessible from outside, like it's passed by reference. So here we have a procedure that is receiving, and we're calling the procedure with 10. That 10 gets copied into variable 1, and we're calculating just adding 2. Now the original 10, if this were a variable, wouldn't change, right? Because it's kind of like a pass by value, and so it would become a local variable inside of the procedure. Whereas if we declare as out, right, any changes that you do to the variable var1 will be available from the outside. That can be assigned. You can pass it a variable, and that variable will change. The value of that variable will change from within the procedure. If it's meant to be passed in as a value, right, and then but then that value can change within the procedure, then you would use in-out. So you would if you pass a variable var1. Notice we can also set it, right, and it would be available. Any change you make to var1 would be accessible outside of the procedure. So here's an example on using in-out. We pass it an increment variable. We set it to 10 originally. We pass it, and then we print it again, right? And notice that we changed its value inside of the procedure by incrementing it by 1. And when we display it, it results that it has changed. Declaring variables, you can certainly you can declare variables outside of the procedure, but you can also declare them inside. Inside, they would be local scope, right? They wouldn't be accessible outside of the procedure, and you can give it data types, using the keyword declare, the name of the variable, and then the data type, where you have the full spectrum of data types, the SQL data types for each one of those variables. So here's an example of declaring a couple of local variables, A string today, B1, B2, B3, with different data types and some default values as well. We're manipulating some data in here. If we have an insert into this particular table, the value of A, that we pass it as an argument. But if you didn't pass it, it'll default to 5. And then once we insert, we can then do an extraction from a particular table, and then print out the results of that particular select statement. We could certainly put this insert statement instead of a loop, right? And as we iterate from a starting index to an ending index, we can generate lots and lots of records based on a loop, mixed in with an if statement and a switch case statement. And as we iterate, you generate lots and lots of data programmatically. Here's another example of just to illustrate the fact that some of these variables are local, so that any changes that occur inside of the procedure are not affecting variables outside. So here we're declaring var2 outside of the procedure. We call the procedure, and we realize that the variable var2 stays the same value throughout, or maybe not. Wait. Okay, now var2, I'm sorry, we're declaring as a global variable, and inside of the procedure we are updating it. Here we're updating it multiple times, just incremented over and over, whereas var2 is a local variable that we initialize into 1. We increment it by 1, but every time we call it, we're still redeclaring it, initializing it to 1, so it always stays at 2. Whereas the global variable, we're incrementing multiple times to 1, 2, 3, 4, and so on and so forth. You have the full power of an actual programming language. You have if statements, for loops, repeats, switch case, so on and so forth. So here we have if a variable is equal to something or is equal to something else, we execute one branch, or we can execute another branch, and we can do queries based on if statements, right? And these can be read from actual tables or views and whatnot. Right? Here's we have a case, right? Or like a switch case. It's a little more powerful than a switch case. Here we are comparing variable 1 against multiple cases, right? Where we have variable 1 compared to 0, compared to 1, compared to, and depending on the value, we might do different inserts, different select statements, different updates, different deletes. This one's a little more powerful, where each one has its own predicate. So each one is validated against its own predicate. And unlike the switch case in other programming languages, only one of them executes, right? So it starts at the first one to execute, you're done. The whole thing just breaks out from the entire structure. Not like Java or that you have to break, right? There's no need for break. There's a couple of loops. There's while do, loop, and repeat. Here's an example of a while, iterating over a variable starting at 0, and as we increment, we increment the variable to 1, and as we're iterating, we're inserting. So here, we're inserting multiple data inside of a table 1, as we iterate over the variable, the outer variable, right? And we can pass in parameters and whatnot. Okay. Here we have a repeat, kind of the opposite of the while loop, right? It's like a do while and the while. Or we can label a loops, right? Almost like a go-to, where we can have multiple labels, and then we can loop to a particular label, like a break. Same thing like where you can break to a particular label, multiple labels, and break to different ones using the loop. And iterate is kind of like continue. Iterate, just jump back to label 1. Or leave, it would be like breaking out of the loop. All right.